अच्छा चलो ये हम स्टार्ट करें कि एक सेकंड में। अच्छा एल्केन्स एल्केन्स में कोई खास नई चीज नहीं है। इट्स जस्ट द सेम ओल्ड एल्केन्स बट वील क्विकली डू दैट। कि एल्केन्स वर CnH2n plus 2 and they were called saturated hydrocarbons. They were non-polar. ठीक है, most of them are non-polar. uh, most of them, all of them are non-polar except maybe they have some other functional group, but they are non-polar. So the only intermolecular force that they're going to have is induced dipole, instantaneous dipole, induced dipoles. And the thing is that these forces, they increase with size. Okay, यहाँ पे there's a point, ठीक है, that point is very important. That is that, and this applies to all organic compounds. ठीक है, whenever you have a bigger molecule, so not just limited to alkanes, any alkane that's got a bigger molecule, it's going to have higher melting points, boiling points. It's going to have stronger ID forces. Okay. And it's going to have uh, it's going to be it's going to be और क्या होगा इसमें? It's going to have it's going to be less flammable. It's not going to easily mix with oxygen, and it's going to be less viscous as well. And you can go on. It's going to have higher surface tension as well. There's going to be more attraction. So all of that. अच्छा, anyways, that's alkanes. We're not going to waste a lot of time. ठीक है, alkanes के अंदर ये कि they are non-polar. They only have one reaction which is called free radical substitution. And also remember, this is not limited to alkanes. Free radical substitution लिख देते हैं, not limited to alkanes. It can happen with any alkyl chain. ठीक है, so that's free radical substitution. What is free radical substitution? It's a reaction which happens with chlorine. So if I have C2H6, it's going to react with chlorine under UV light. Okay, that is essential. Or it could be bromine as well. Normally, it's not fluorine and not iodine. And any of the H's could be substituted with Cl. And HCl would be a byproduct. So it could be any of the H's. Okay, so it could be C2H4, Cl2, or it could be C2. You'll be left with just one H, and all five could be Cl, right? So any number uh, or position can be substituted because you're going to get multiple compounds. The trouble with that is it's a reaction which has very low yield, because it's completely random. Okay, so it's kind of random and it produces multiple products. So it could be any of those products that are forming. Okay. Ibrahim, clear is arc middle. Is this clear?
Yes.
Yes.
अच्छा अब इसके steps क्या थे? Step number one. Step number one is called what initiation? अच्छा, what happens in initiation is that free radicals are formed. Okay, that's step number one. So you should still know what the mechanism is. Okay, you've got a Cl2 molecule and half arrow. One electron goes to this side. ये कौन सी fission है? This is homolytic fission. And you get two Cl radicals, which we discussed yesterday. Okay, they are highly reactive. Okay, they've got incomplete bonds. So since they're highly reactive, they immediately start the propagation step. So you start with step number two, and that's your propagation step, where one radical gets converted into another radical. He converts to another. Total radicals, they remain the same. अच्छा, तो propagation में what happens is that you've got C2H6 that gets attacked by the Cl radicals because they want to complete their bonds. So the Cl would form HCl, would steal one of the H's, and your C2H6 will become C2H5. बल्कि इसको structural formula लिख लेते हैं. It's CH3CH3. So it becomes CCCH2, right? The carbon becomes a radical. Then what this carbon radical would do is that it will attack, it will attack a Cl2 molecule and steal one of the H's from there. So it will become complete. It will become CH3, CH2, and now a Cl has joined it. But the Cl2 molecule lost a Cl, so it's now a radical now. And it just repeats endlessly. But basically what has happened is that one Cl is now substituted. Now you can do the same thing, repeat this again, and another one would get substituted. So one is already there now, CH3, CH2. The Cl radical would attack again. So Cl radical khatam nahi ho raha, ठीक है? So it will attack again. Let's say it steals one of the H's on the left side now. The second has complete bonds. So another HCl is formed. And then the Cl2 molecule, वो जो radical बना है CH2Cl, this carbon will try to complete its bond and uh, it will steal one of the H's. ठीक है? तो ये clear है कि this is propagation step. You studied this in AS as well. ये clear है? Middle
Yes.
clear है? इब्राहिम ठीक है. अच्छा, अब ये कि this thing ends with a termination step. ठीक है, so your final step is termination. And that's step number 3. उसमें any of the radicals, जो भी, whichever got produced. So for example, you have a CH3, CH2 radical getting produced. And the bonds are incomplete. So there's another radical and those bonds are also incomplete. So the two carbons can simply get together and they can form, मतलब बीच में ना CH2 जो है, they can just form a bond with each other. And you'll get a product which is not a radical anymore. ठीक है? So any of these steps could be, ऊपर कोई भी दो radicals जो बने हुए हैं उनको उठाओ. You got a Cl which is a radical. Both of them want to complete the bonds. So they simply join up with each other. ठीक है, clear है? This is EVOF, free radical substitution. Is that clear?
Yes.
Hala made it. So that's it. So that's free radical substitution. Remember, it can happen in any alkyl chain. ठीक है? Iska mechanism, we just did the mechanism. It's got a low yield because a number of products are possible, right? And that's about it. ठीक है? अच्छा, बस ये alkanes खत्म हो गया. So what we are now going to start is something that's going to be very important, and that's the first thing is we'll discuss alkenes and we'll also discuss benzene as well. Okay. So what I'm going to do is we're going to first study the structure of benzene. Acha, alkenes are like really important in A levels. Because whenever they talk about benzene, they will kind of also discuss alkenes with it. Okay, so your AS alkene reactions are kind of, they would always come into discussion in the question. So because benzene is very similar to alkenes. So structure of benzene and alkenes, and we'll note down what the difference is. क्योंकि इसके बाद हम मतलब हम alkene को तो पढ़ेंगे, ठीक है, because that's important. But there's going to be a whole story about benzene now. ठीक है, I mean, a lot of A levels chemistry that's about benzene. अच्छा, so we're going to start with the first thing, which is कि remember when carbon makes a double bond. Uh, so carbon in double bonds is sp2 hybridized. Keep that in mind. Here, what that means is that the carbon is going to look something like this. One electron bonds over here, one electron bonds over here. Here, one of the electrons is bonding over here. It's a fan shape, 3 bonds, trigonal planar. And then it's going to have a p orbital, which would not be bonded to anything. So this is exactly what carbon would look like. Here, carbon would, its outer shell, here 2p-y1, 2p-z1, right? These are the 4 electrons of carbon. Okay, but when this is the outer shell of carbon. So when it's bonding and forming a double bond, तो क्या होगा? 3 of them will change into sp2 hybrid orbitals. ठीक है, this one would also be sp2. The third one would also be sp2. And the fourth one would still be 2pz. ठीक है, so one of the p orbital does not change shape. ठीक है, that remains exactly the same. So there are 3 hybrid sp2 orbitals. So basically what's happening is There's an atom trying to pull electron on this side. There's an atom trying to pull electron on this side. There's an atom trying to pull the electron on this side. So three of the orbitals, they change shape. So you just give them new names instead of calling them S or PX or PY, because they have completely changed shapes. They have been stretched in three different directions. Instead of calling, क्योंकि S जो होता है, that is spherical, P is dumbbell shaped. So they don't look like 2S or 2PX or 2PY. So you start calling them with, you just give them new names, and you give all three the same name because they look exactly the same. ठीक है? So you clear up what is hybridization? Is this clear? Ibrahim, clear? Isaac, Qasim, Minal, is this clear?
Yes, sir.
Achha, so hybridization is what? It's got a definition as well. They can ask the definition. It's the mixing of orbitals to form new hybrid orbitals. ठीक है? It's the mixing of orbitals to form new hybrid orbitals. अच्छा, इसको arrow भी बना देते. One atom over here, one over here, one over here. And the last one is actually, it's not bonding to anything. So the fourth electron is kind of unused. So three of them bond. So three of them are bonding, while the fourth one initially not doing anything. The P is not doing anything. अच्छा, तो alkene में क्या होता है? I'm just going to pick this and अच्छा, so इसको रोटेट कर लेते हैं. ठीक है. अच्छा, so this is how an alkene is going to get formed. Okay, there'll be two carbons trying to bond with each other, and अच्छा, इस साइड पे probably H होगा, so that's H bonding. So H is pulling one electron over here, one electron over here, one electron over here, one electron over here, and the third electron of carbon is being pulled by the neighboring carbon atom, right? So they would overlap in the middle and they would form a sigma bond. अच्छा, ये चीज़ बहुत important है, ठीक है, A levels में. So they would bond together in the middle. They're going to overlap. The middle में ना they started overlapping. इस कार्बन को उठा के सीधा कर लें जरा. हाँ. अच्छा, they'll start overlapping. And so this is, now you need to know the details. This is an sp2 overlapping with hydrogen's s orbital. And this is exactly the same. Carbon ka sp2 overlaps with s. This is kind of the same, sp2 overlapping with an s, or the s overlapping with carbon's sp2. As a middle में the sigma bond is formed. This is your sigma bond. It's carbon's sp2 overlapping with the other carbon's sp2. ठीक है, ये clear है? Minal, Isaac, Qasim, is this clear? Brain clear? Hala clear?
Yeah.
Yes.
And then you have these useless p orbitals, which are not doing anything initially. What are they going to do? They're going to start overlapping with each other as well. So they'll overlap from the top and from the bottom. They're going to try and pull each other's electrons. But since they're both carbon, they're equally electronegative, so the electrons are kind of hovering in the middle, right? And that's your pi bond. So it's a p orbital overlapping with a p orbital, and that's basically forming your pi bond. Okay, that's it. So this is what alkenes would look like. Okay, that's That's what alkenes. So that's what alkenes look like. सही है. अच्छा अब ये कि uh, now the important thing is, ठीक है, the thing that they're going to ask you very frequently, and they're going to compare it with benzene as well. That alkenes जो है ना, they have a very high charge density double bond. The negative charge is very, very concentrated at this point. I mean, there's a lot of electrons over here, and in a very tight area. ठीक है, so so there are a lot of electrons grouped together in a very, very small space over here. So it's a very high electron charge density area, right? Or double bond, you can call it a double bond. ठीक है, is this clear? You clear? It's very high electron charge density double bond. Is that clear?
Yes.
Achha, so who gets attracted to electrons? Electrophiles get attracted. So the thing is, alkenes, जो है ना, they are very strongly, I mean, not they are, or they attract very, तो उल्टा कर लेते हैं. Alkenes strongly attract electrophiles. And therefore, most of the reactions are electrophilic, and specifically electrophilic addition reactions. ठीक है, ये clear है? No, ये clear है सारों को. electrophilic addition we studied AS में वही किया था ना. ठीक है, इसाक कासिम भी
Yeah.
clear है.
Yes.
So, I said now we're going to study about benzene. ठीक है, now this is alkenes. Make sure this is what an alkene looks like. This is what the double bond looks like. The double bond, the electrons are like really, really packed, which is why it's got very high charge density, which is why it attracts electrophiles, right? It's two p orbitals overlapping. And let me write this shape as well. This is 1 second, sp2. This is your p, and this is what, trigonal planar, and the angles are 120 degrees. Because it's fan shaped. So now coming to benzene. So this is just going to be a brief introduction to benzene right now. Firstly, what is benzene? So you get like big marks, like you get 5, 6 mark questions just on the structure of benzene. So what is benzene? First thing. So benzene, technically, it's the easiest way to visualize benzene. I mean, it's helpful, but remember, I'm writing it's not the correct way. Yeah, but that's the easiest way of looking at benzene. ये इधर छोड़ा. ठीक है. अच्छा, so and we're going to have H atoms, right? So these are your H atoms. So keep this in mind, you're not going to draw this, although this can be acceptable. So it's like a cyclic hexene with alternating double bonds, right? And this structure over here it's got a name as well, which is Kikuele structure, but again, uh, it just makes it easy to visualize. Like if you want to figure out whether it's sp2 hybridized, so you would notice that each carbon atom is making a double bond, right? So they all sp2 hybridized. Okay, so if somebody's going to ask you what the bond angle is, so you would tell them that it's 120 degrees. So this is C6H6, right? Ye clear? This thing.
Yeah.
So not again, this is not to be used. But the reason I'm doing this is, okay, just it's easy to visualize if you want to make bonds or if you want to figure out. It's just three alternating double bonds. Okay, now the correct structure is we're gonna come to the correct structure, but we're gonna draw the complete detailed correct structure, and the complete detailed correct structure is that I'm gonna pick this. Where's my? I'm gonna pick my sp2 hybridized carbon atom, right? This one, and I'm gonna draw they have there are six carbon atoms. इसको थोड़ा सा सीधा कर लें कि जिसको ले जाते हैं ऊपर। ठीक है। So I'm going to copy this, and I'm going to attach six of these together. ठीक है, so they're two sp2 hybridized carbon atom, and they are forming a sigma bond right in the middle over here. ठीक है, and let me ऐसा कर लेते हैं. So you clear? It's two sp2 hybridized carbon atom trying to form a sigma bond. Is that clear?
Yes.
So then there is another one, and that's trying to make a sigma bond as well. तो मैंने यहाँ पे कर दिया, ठीक है? So they end up forming a sigma bond. Then there's another one, and I have to, I think, yeah. So that one is also trying to make a sigma bond. अभी तक सही बन रहा है, ठीक है? And then there's, eventually there would be six of these. So this is सही बन जाए. This is trying to make a sigma bond. And then finally I have the last one. So this last one is also trying to make two sigma bonds. So it's six carbon atoms bonded to each other, and they're forming sigma bonds. You will be asked to draw this as well. ठीक है? ये clear है? और इनको थोड़ा सा let me rotate these. अच्छा, is this clear that six carbon atoms all forming double bonds? Ibrahim, clear is Isaac. Hala, is this clear, Qasim?
Yes, sir.
ठीक है. So double bonds and all of them are sp2 hybridized, and I haven't made the double bond yet. ठीक है. The first thing, the outer bonds, those are obviously being made by H atoms. I said now the p orbital, the unused p orbital, they would start to overlap. So this would overlap and they would form a double bond in the middle. ठीक है. Clear? So that's a double bond over there. These would overlap and they would also form a double bond on the side. ठीक है. And then there's a third double bond, which is this. So काफी अच्छा बन गया. So clear. So is this clear that you're forming three double bonds? Is that clear? ये
Yes.
clear? ठीक है. Qasim, Hala, Minal, Ibrahim, is this clear?
Yes.
अच्छा, now the only thing is that it's not going to be three double bonds. What eventually happens is that since वरना normally क्या होता है? It's normally it is that normally in normal situations, two p orbitals they overlap and you get a pi bond, right? You got a pi bond over here as well, right? Their electron densities merge, their electron densities merge. Okay, so they all start overlapping. But in this situation, what happens is you don't just have two p orbitals lying sideways. It's six of them. And eventually what happens is that if this orbital over here is overlapping with this one, it can also simultaneously overlap with the other one as well. Okay, what's stopping it? Nothing is stopping it. So basically, all the p orbitals they become delocalized. So this p orbital also can decide to overlap or merge with the one on top, right? So eventually they all start to overlap. I mean, these two in the middle can overlap. It's like one big pi bond. Okay, and they all start to overlap. ये clear? Is this thing clear?
Yes, sir.
तो ये और ये भी overlap करके this and this can also overlap. So basically the electrons get delocalized, and I mean the electrons over here can overlap with this one as well. And these can overlap as well. So basically at the end of the day, you get just like your alkene. Alkene mein you had just one pi bond. Over here you were supposed to have three pi bonds, but they all overlap, and this is called a delocalized benzene electron cloud. But it's not delocalized everywhere. It's still kind of localized. It's the delocalization is only on the six carbon atoms that you can see. So this is the delocalized. Spelling क्या होता है? Localized benzene pi-electron cloud. And this is also called the benzene ring. ठीक है, so basically the correct way of writing benzene is it's not three alternating double bonds. the correct way is you don't show the double bonds. हमारे बाकी H है. अच्छा, now the correct way is कि you show a ring. ठीक है? And the ring kind of shows that you had three double bonds, but they all got delocalized. Is that clear? और इसका जो skeletal formula है, that's this. Shape किस तरह आती है, एक सेकेंड. So this is the skeletal formula. ठीक है? Is this clear? This thing? ये clear है सारों को?
Yes.
तो अब उसकी फिर नेक्स्ट क्लास में हम करते हैं डिटेल, क्योंकि you will be asked a 6 mark question on this and they'll ask you to describe the structure of benzene. ठीक है? So basically it's you start off with an alkene, but it's three alternating double bonds. ठीक है? Remember not to draw this structure. ठीक है? This is not the correct structure. ये जो Kikuले structure है. Uh, this is the correct structure and this is the ये जो सबसे bottom वाला है ना, that's how you actually write benzene. That's the skeletal formula of benzene. ठीक है? चलो ठीक है, कल कंटिन्यू करते हैं. ठीक है? और
Okay.
फिर इसको फर्दर डिस्कस करते हैं. चले, ओके, अल्लाह हाफिज.
Okay.